Power spectral density, which in short we call it as PSD. Okay, so can anybody tell me what is this power spectral density? What information it will give you? Anybody can answer me. Okay, I will only tell you. So PSD, power spectral density, will help us to identify how the power is associated at each frequency component. Okay, so I should have the, if I have a signal x of t, then for that I need to find the power spectral density, which is denoted with as x of t. Okay, so let me consider I am taking the power spectral density for this x of t, then it will give me how exactly the power is distributed. I'm just drawing some random signal here. Okay, so what it will show at each frequency, sorry, this is S x of f, not t, Sx of f is the power spectral density of this x of t. Okay, so what it will tell us, how the power is distributed at different frequency components, that will be given by this power spectral density. Okay, so here what we need to do is we need to calculate this power spectral density for the line codes. Okay, so unipolar RZ, NRZ, bipolar NRZ, polar NRZ, Manchester encoding, or for all these four schemes, we need to calculate the power spectral density. Okay, so to calculate the power spectral density, we have two approaches. The first one is deterministic approach. Deterministic approach. And the second one is stochastic approach. What do you mean by deterministic? Deterministic. The word deterministic means it's the, like, we will be knowing the information prior. Okay, that is what your deterministic approach. So maybe whatever sequence I am transmitting, maybe 101101 I'm transmitting, so this will be known to me prior only. Okay, so if that is known to me prior, that is said to be the deterministic approach. Stochastic approach, it is also said to be the random approach. Okay, in this random approach, will not be knowing what data is coming to us. Okay, see here I'm talking. Okay, so the receiver will not know what I am speaking, what I'll be speaking. Okay, you can estimate it, but exactly the receiver will not understand what I'm speaking. Okay, so that is what random process or the stochastic process. Okay, so deterministic process, anyway we are not interested. We are interested with the random process, because in the communication we will not know what exactly is being transmitted. Okay, so that is the reason, like, we have to go with the stochastic approach only. Okay, so in the stochastic approach, see, as I have told you, we need to calculate for the unipolar power spectral density should be calculated for unipolar NRZ, polar NRZ, bipolar NRZ, and Manchester encoding, split Manchester. Okay, for all these four, we need to calculate the power spectral density. Okay, power spectral density, as I've already explained, it will describe how the power of a signal is distributed over a frequency. Oh, okay. So that will be given by this PSD. So we need to calculate for all this. Before going to this all, let us first identify how to find the power spectral density. Okay, so in order to find the power spectral density, let us consider some basic mathematical equations. And once we are familiar with the mathematical equations, then we'll go to the each unipolar, polar, bipolar, Manchester will go in detail with each format. Okay, each format. Okay, so first let us analyze how the signal will, how the PSD will be calculated here. Okay, so let us consider that I have some non-return to zero NRZ pulse. Okay, NRZ pulse, in the sense I'll have the duration as TB. Okay, and its amplitude will be 1. Okay, so let this signal be denoted with V of t. Okay, but in my unipolar NRZ, how it will be? I may have the signal. See, initially I may have 1, next to 0, 0. So the amplitude should be 0. Then I need to have 1 like this. I need to have no. See, if this is the form, this is the binary data, then my signal will be in this way. Okay, so in order to frame that signal, let me denote that the complete pulse as this complete signal as x of t, as we were doing before. The same terminology I'll use here also. So x of t is the complete signal. Okay, x of t is defined as k is equal to minus infinity to plus infinity ak into v of t minus kt. Okay, so what is this? See, this is the general pulse. Okay, general pulse which will be used in the NRZ format. NRZ format. Okay, in the NRZ format, you will have the pulse like this. For complete one TB duration, the amplitude will be 1 or A. Okay, that is what for this AK is used here. So AK indicates AK will be equal to 0. I'll write down only. Anyway, that is also important. Where AK value will be equal to A for symbol 1, and it may be equal to 0 for symbol 0. Okay, for symbol 0. Okay, so this AK is for that. Okay, and this V of t minus kt, see here I have a pulse. Okay, again somewhere here I should have the pulse. Okay, so it is a shifted version of this original signal. That is the reason we have represented with this equation. Okay, so this is the general representation of your NRZ format signal. Okay, this is a complete representation of your NRZ format signal. Okay, so here what we need to find is, we need to find the power spectral density. Hope you all are following. Anybody gets any doubt, you can ask me. Okay, so this is, you may ask me, mom, here you have written TB and here you have written T. Okay, so generally let us take it as T only, and later on we can replace T with TB. Okay, this is a generalized equation which I have written from 0 to t I have. So that is the reason V of t minus kt. Okay, so the this is the shifted version of this signal, V of t signal. Okay, and we are representing the complete signal as x of t. Okay, so here we need to calculate the power spectral density of the of this signal x of t, whatever x of t I have. For that I need to find the power spectral density. So in order to calculate this, see, all this explanation whatever I am doing, you need not write it in the exam. So that is the reason whatever I have written in the notes, you can just blindly write that. Okay, see, here I'll be adding some extra things only to make you understand. Okay, so don't worry about it. Okay, so I need to find S, x of t is the input to some LTI system with h of t, or like, okay, here I'll take the exact representation. V of t is a signal that is given to this LTI system whose one second. Okay. First, let me tell you how generally we'll calculate this power spectral density. Okay, so x of t is some signal. Okay, x of t, and this I'll denote with y of t. This is like as an example I'm taking. Okay, so where x of t is the input signal and y of t is the output signal, and h of t is the system function. Okay, so if I want to find the power spectral density of y of t, I will be generally representing with sy of f, which will be equal to, if for this the power spectral density is given by sx of f, and for this it will be mod h of f whole square. Okay, then it will be equal to mod h of f whole square into sx of f. Okay, sx of f. Okay, this is how we generally calculate for the continuous signals. I don't know how many of you knows this, but it is already dealt in your previous random process or whatever subject you have studied with respect to the random process. You would have already seen this kind of equations. Okay, so this is how we will be calculating. Okay, but here I have the discrete system or digital system. Okay, so for that A will be the AK will be the input. Okay, AK will be the input, and this will be giving to the V of t. V of t. This is the system with function V of t, and I have to get x of t. Okay, so here what I need to find, I have to find Sx of f. Okay, to find this Sx of f, I need to take mod V of f whole square. How we will be taking for this, in the same way we need to take for this, and again for this I need to find the power PSD of AK, PSD of AK I need to find. Okay, PSD of AK I need to find. Okay, so the complete equation for this is generally given as Sx of f will be equal to, this is a standard formula. See, all this whatever I have explained you here, it is only for your understanding. So because directly if I write Sx of x as like this kind of equations, you'll not understand. Okay, that is the reason I'm just trying to explain you, correlate with the actual process. Okay, so Sx of f generally it will be found by taking 1 by t mod V of f whole square, which is nothing but this signal. Okay, into summation n is equal to minus infinity to plus infinity Ra of n e power minus j 2 pi fn t. Okay, so this is nothing but the power spectral density of AK signal. Okay, AK signal, this signal, whatever signal I'm taking here, it is discrete signal. Okay, discrete signal or digital signal. Okay, digital signal will have two values. The discrete signal will have some specific finite values. That is the only difference. Okay, so this is the power spectral density of AK. Okay, here what is this Ra of n? It is nothing but the autocorrelation function. Okay, so there is a relationship between autocorrelation function and the power spectral density. Can anybody tell me the relationship? Autocorrelation function. If I take t, it is a continuous time domain. If I take n, it is a discrete time domain. Okay, so Ra of t, if I take, then its Fourier transform will be equal to Sx of f. Okay, Fourier transform of autocorrelation function will give you the power spectral density. Okay, this is a relationship you have already. Okay, so here it is not continuous. This AK is not continuous signal. It is a discrete signal. That is the reason I have taken DFT of this AK. Okay, Ra of n e power minus j 2 pi fn t. Okay, otherwise if it is Ra of t, how will you calculate? Integral minus infinity to plus infinity Ra of t e power minus j 2 pi ft dt. This is how you take. But since it is discrete signal, I'm taking this as Ra of n. Okay, Ra of n is the discrete signal. So I cannot take integration. I need to take summation. That is what is this. Okay, so this is the standard equation that we use to calculate power spectral density of the signal x of t. Have you understood? Have you understood what I have explained you here?
Yes, ma'am.
Okay, so you need not worry about all this story. Whatever I have done from here to here, if you understand, it's well and good. If you're not understanding also, it's okay, fine. You don't worry about all this. Okay, this is a main equation that we'll be using to calculate the power spectral density of any given line codes, any format you have. This is what the formula will be using. What is this V of f? V of f is nothing but the Fourier transform of this V of t. Okay, so let us find V of f also. How I will just show you how to calculate area of n and what is V of f. Everything will do now. Otherwise, this is the formula to calculate power spectral density of any unipolar or RNZ format. RNZ format. Okay, so now you need to know what is V of f. Okay, so V of f is this signal. Somebody has turned on your. Srinivas M. Srinivas M. Srinivas.
Ma'am.
Mute yourself, no, ma.
Ma'am.
Okay. Mute. No. See, ask your friends to rejoin because we have 4 derivations which is related to this. Okay, so that is the reason. Please ask your friends to rejoin. Okay, fine. Okay, so now generally if you observe V of t is nothing but the rectangular pulse, so this V of t can be generally given as rect t by t. Okay, here what we have done is we will be shifting this, we'll just write this as, for simplicity, will take as minus t by 2 to t by 2, its amplitude will be 1 and this will represent as V of t. Okay, so that is the reason V of t can be represented as rectangular pulse. V of t will be equal to rect t by t. So what you need to do, you need to find the Fourier transform of this one, so that you'll get V of f. Okay, so V of f will be equal to, so this is the rectangular function, so when you convert it to the frequency domain, you'll have sinc function. Okay, so V of f will be equal to your sinc function. I will write it again. It will be equal to t sinc ft will be the frequency domain representation. Okay, anyway, this you have to remember, because either you need to calculate or you need to remember. Okay, calculate in the sense, what you need to do, you have this function, so what you'll do, from minus t by 2 to t by 2, you'll take the integration from minus t by 2 to t by 2. This function, the value will be equal to 1 e power minus j 2 pi f n t dt. Using this, you can just find, you'll get t sinc ft. Okay, sinc is nothing but sin pi t by pi t. Okay, so that's what you can either derive it or you can just write it directly. Okay, it's left to you. If you can remember, you can write it directly. Okay, so I have got V of f, so that I can substitute that V of f in this first equation. Okay, this is the first equation, so that in place of V of f, I need to substitute this t sinc ft. Okay, next, what is this Ra of n? Okay, Ra of n, as I've told you, it is nothing but the autocorrelation function. Ra of n is nothing but the autocorrelation function. Autocorrelation function. What do you mean by correlation? What is the use of correlation? Can anybody tell me? What is the use of correlation? You people have studied in your DSP as well, right? Even in lab, you did autocorrelation, cross correlation and all that, right? Correlation. Tell me, no, whatever you know, you tell me. It's okay, fine, no problem. Even if you're wrong, it's okay. That's what I'll be telling always. Srujan, are you there today? Srujan. You people
Yes,
are just on it and
ma'am.
you're going. Yesterday you were not there, no, Srujan?
Yeah, ma'am. There was some work, so I went out.
Okay, fine. Tell me, what is the use of correlation? First tell me correlation, then I'll ask you what is autocorrelation and cross correlation. Correlate. Generally we'll say, correlate this with the previous one. Like that we'll be saying, right? What do you mean by that? General meaning of correlation. Anybody else? Hitesh? Purnima?
Similarity of signal.
You need to find the similarity between the two signals. Okay, so autocorrelation. Why you're not saying Hitesh then? When you know, you can say no, you can unmute yourself and say it, right?
Okay.
Please see, when you know something, you just tell it. That's what I'm telling you. Even if you're wrong, nothing is going to happen. We all will learn together. Okay. So again, see, I have to come back here, ask each and every person, then you'll reply. That should not happen. Okay, please, from next time, if you know something, you just answer it, whoever it is. Okay, I need not ask name wise. Okay, if you know, you tell the answer. Even if it is wrong, no problem. Okay, no problem, I'm telling you. Okay, fine. So correlation in the sense you need to compare any two things. Comparing two things is correlation. Okay, so autocorrelation, cross correlation. In autocorrelation in the sense we'll be comparing two signals, two of same signals, but you'll shift in time domain. Okay, so shifted version of the same signal will be compared. That is autocorrelation. Cross correlation, two different signals will be compared. Okay. So here RA of n is nothing but the autocorrelation function. Okay, so here you need to find the autocorrelation of AK. Okay, why AK? AK is the random signal here because we don't know whether we'll get a 1 or we'll get a 0. Okay, random process. Since it is random process, I have to just consider which is a random variable here. So AK is a random variable. Why I'm saying it is a random variable? Because I don't know whether my value, whatever information signal I'm getting, it will be either a 1 or a 0. Okay, so that is the reason this is a random variable. That is the reason here it is mentioned as RA of n. Okay, this A indicates it is nothing but the autocorrelation function of AK. Okay, so here you need to find RA of n. So RA of n can be calculated as ensemble average or the mean value of AK minus n. This is how generally we give, or in terms of equation we can represent as summation I is equal to 1 to I. What is this I? I'll tell you. AK into AK minus n of I Pi. Okay, Pi is nothing but the probability. Okay, probability of occurrence of 1 and 0. Okay, that is Pi. Okay, and AK minus n for each iteration of I, where I is from 1 to I. This I will be the number of product terms. See, here I have AK n minus 1. Okay, so I may have A1 if n is equal to some 0. Okay, I may have A1 okay, or I may have A2 when n is equal to 0, or if n is equal to 1, so I may have A1 minus 1, something like this. Okay, so this I indicates for each iteration, this capital I indicates for each iteration how many product terms I'm getting. That will be your I value. Okay, so using this equation I need to find the autocorrelation function of the random variable A or AK. Okay, so this is a formula to calculate. See, all this also you need to remember. This also you need to remember. Okay, so this is your RA of n. Using this we'll be calculating the function. This let me consider as equation 1. This let me consider as equation 2. As and when we go for the specific topic like unipolar NRZ, polar NRZ, you'll understand very clearly. Okay, right now this is how we'll be calculating the PSG of any given signal. Sx of f is nothing but the power spectral density of x of t, which is given by 1 by t mod v of f whole square. This v of f is nothing but the rectangular function. That rectangular function's frequency domain Fourier transform you need to substitute here, and this summation n is equal to minus infinity to plus infinity Ra of n, which will give you the autocorrelation function, and the autocorrelation function is getting multiplied with e power minus j 2 pi f n t. Okay, so this is nothing but the rectangular functions Fourier transform, and this is nothing but the DFT of the random variable ak. Okay, so this is how we'll be calculating the power spectral density. Okay, so anybody have doubts here, you can ask me at the end, because once we go with the problem, you'll understand very clearly. Okay, so let us go to the first topic. The first one in this is unipolar NRZ. Unipolar NRZ format. Okay, or I can write as power spectral density of NRZ unipolar format. Anything is fine. Or power spectral density of NRZ unipolar format. Okay, so for this I need to find now. Okay, so as you know, how the NRZ format will be unipolar, how it will be, 1 will be represented with positive a, 0 will be 0, positive a, 0, a, right? This is how we represent, right? If you recall, the unipolar NRZ format will be represented in this way. It means that the AK value will be equal to a, okay, for symbol 1, and it will be equal to 0 for symbol 0. And each pulse will be of duration TB. Wherever you take, for this also the duration will be TB. This will be TB. Even this duration will be TB. This duration will also be equal to TB. This duration is also equal to TB. Okay, so these are the AK is equal to A, and AK is equal to 0. AK will be equal to 0 for symbol 1, and AK will be equal to 0 for symbol 0. Okay, and each bit will be of TB duration. That's a TB seconds. Okay, will be of TB seconds. Okay, so here we need to calculate for two cases. Okay, case 1, let us first take case 1. Okay, first before going to this case 1, I will just write the equation which we have to calculate power spectral density. Power spectral density can be calculated in general as Sx of f is equal to 1 by t mod V of f whole square, summation n is equal to minus infinity to plus infinity Ra of n e power minus j 2 pi f n t. Okay, but here each bit duration is TB seconds, so wherever you have t you replace with TB. Okay, so this is a specifically for unipolar NRZ format. Okay, so Sx of f can be calculated by using this formula. Okay, and let us now first find V of f. As I've already mentioned, V of t, it is nothing but rect t by TB here. Okay, why it is TB? Because TB is a duration between the complete pulse. Okay, so that I need to find Fourier transform of this one, which is nothing but V of f. V of f will be equal to rect t by TB. So I'll have the amplitude as TB. Okay, and the rectangular pulse time domain, if I have a rectangular pulse in the frequency domain, it would be sinc function, sinc f TB. Okay, sinc f TB. This is the V of f. So this I'll name as equation 1, this equation 1, okay, this I'll name as equation 1 and this I'll name as equation 2. This equation 2 I can substitute in this V of f, okay, V of f. Now next I need to find area of n, okay. In order to find area of n, I will take two different cases. First, now this is step 1, next step 2, I need to calculate calculation of autocorrelation function. RA of n. This I need to calculate now. Okay, in order to calculate this, I will take two cases where in case 1, I'll just consider n is equal to 0. Okay, okay, fine. Before going to this, let me write the equation for autocorrelation function. What is it? RA of n is calculated by using the formula. Directly I'll write this. I is equal to 1 to I. What is it? AK minus n I pi. Okay. So here I will just take case 1 when n is equal to 0. Okay, I am taking case 1 when n is equal to 0. When n is equal to 0, what happens to RA of n? RA of n will be equal to RA of 0. Wherever I have n, I need to replace with 0. So it will become I is equal to 1 to I AK into AK I pi, right? Now if you observe this AK, so if I have here also I have AK and here also I have AK. So what are the possible products I'll get? Possible products. Can anybody tell me what will be the possible products? AK value can be either a 0 or a 1 or a. Okay, so what will be the possible products here? These two are getting multiplied, no? That's why I'm calling it as products. So can anybody tell me what will be the possible products here? I can have A into A, right? Yes or no, ma? One. Huh?
Yes, ma'am.
I'll have the first combination as A into A and the second combination as 0 into 0, right? Because this is also AK and this is also AK. This AK value can be A. If this is A, even this will be A. If this is 0, this will also be 0. So how many products I can get here? Only 2 products. 2 products I can get. Okay, so this I will be equal to 2 now. This I will be equal to 2 now. Okay. So and this A and 0 are equiprobable, right? Equiprobable means, what do you mean by equiprobable? I may get a 0 or I may get a 0 or I may get a 1 symbol. One symbol it is A, symbol 0 it is 0. Okay, so I may get this or this, symbol 1 or symbol 0, anything, both. In this both I may get, see, tossing a coin. I think you people know the tossing of a coin. So it can be either a head or a tail. Okay, so at each toss, what will be the probability? Can anybody tell me the probability of getting a head?
1 by 2.
1 by 2, right? How it is 1 by 2? One head, it can be either a head or a tail. The total number of events are 2. 2 events I'll get, and in that I want only head. So head can occur only one time. Okay, so actual occurrence divided by total number of events. So 1 by 2. In the same way, here I can get either a 0 or a 1, right? So what is the probability of getting a 0? Probability of getting a 0? What is the probability of getting a 0? I'll write as AK is equal to 0. What is the probability of getting AK is equal to 0? Same. How you have done for heads and tails, in the same way you can tell me here also. Out of 2 events, 1 by 2, right? If this is head, if this is tail, then the probability of occurring 0, which is nothing but the head, is 1 by 2. In the same way, the probability of occurrence of 1, which is nothing but the tail, is also 1 by 2, right? So since these are equiprobable, the probability will be equal to 1 by 2. Okay, so this is nothing but here pi. Pi will be equal to 1 by 2 for ak is equal to 0 or ak is equal to 1. Okay, so now I came to know what is I, what is pi, and what are the products that I'm going to get. Okay, so now what I need to do, I'll just substitute it. Anybody has got any doubts until here? Anybody has got any doubts until here? Is it clear to all of you?
Yes, ma'am.
So here I need to calculate RA of 0, which is nothing but summation I is equal to 1 to 2. When n is equal to 0, I'll have only two products, EK into AK of I PI. Okay, this I need to calculate now. Okay, so this will be equal to AK into AK for the first product. It can be A into A. A into A is A square, right? A 0 into 0, it will be 0. Okay, so the first one can be A square. Okay, or you want me to expand it? I'll just expand it. AK into AK, the first product P1. Okay, plus AK into AK, the second product into P2. Okay, so this will be equal to, first I'll take A into A, the first product is A into A, and its probability is 1 by 2, plus the second one is 0 into 0, and its probability is 1 by 2. So this will be equal to A square by 2. Okay, A square by 2 plus 0, which will be equal to RA of 0 is nothing but A square by 2. Okay, so this is the first case. Only like when n is equal to 0, I've got. Okay, I've got as A square by 2. Now let me go to case 2. Here I cannot calculate for n is equal to 1, n is equal to 2 like that. Instead, I'll just take some common strategy where n not equal to 0. N not is equal to 0 in the sense here RA of n will be equal to same. This equation will remain same, but I need to find out how many products I'm going to get here. AK of AK minus n I PI. Okay, so I need to find out how many products I may get. Okay, so AK value, AK and AK minus 1 n. Okay, so AK and AK minus 1, these two are shifted versions, right? So I need to take the possible values. Okay, so AK may be A, the first product, let me take A. So the second one, I may get a 0 or I may get a, right? Yes or no? Are you understanding? If I fix the first term as A, the second term can be either a 0 or a, right? So I may have A into 0 or A into A. In the same way, the third one, I may get 0 in 0. If the first one is 0, the second one can be a or it can be a 0. Right? These are the four combinations I'll get. Yes or no? Same, heads and tails together. Toss it twice. How it will be? That is what the same. Same way this also. See. Here again it is AK and AK minus n. Okay, first I'm fixing AK value to A. Okay, so if this is A, the other one AK minus n can be either a 0 or a. Okay, so there is a reason I've got two combinations. In the same way, if I fix AK to 0, my second one can be either A or a 0. Okay, so how many products I've got here? Total number of products I've got here. How many? Will you get any other products apart from this? Any other combinations?
No, ma'am.
So you will get only 4 combinations here. Okay, so my I value here will be equal to 4. Okay, so this will be 0. This is A square. This is again 0. This is again 0. Okay, and can you tell me what will be the probability of each product? Probability?
1 by 4.
Very good. 1 by 4. Okay, probability of probability of AK is equal to, I'll write in general. Pi will be equal to 1 by 4, because for this complete thing, if I want to get A into 0, it is one combination only. So 1, the total number of events are 4, 1 by 4. Okay, so for each it will be 1 by 4 only. Okay, now I've got Pi also, I've got AK into AK minus n also. Now I have to substitute in Ra of n. Ra of n is equal to, the first one is 0 into the probability 1 by 4 plus A square into 1 by 4 plus 0 into 1 by 4 plus again 0 into 1 by 4. Okay, so I'll get this as A square by 4. Okay, so finally I can summarize case A, case 1 and case 2 together. Case 1 and case 2 together I can summarize as Ra of n is equal to A square by 2 for n is equal to 0 and A square by 4 for n not equal to 0. Okay, anybody has got doubts until here? Anybody has got doubts until here? This I'll name as equation 3, right? First equation is the original PSG equation, then V of F equation, then finally this Ra of n. Okay, anybody have got doubts until here? You can ask me. Okay, otherwise Sx of f is equal to 1 by TB. I'm taking the original equation which I have, equation 1. This is my equation 1. Summation n is equal to minus infinity to plus infinity Ra of n e power minus j 2 pi f n TB. Okay, this is the equation I have. Now I'll substitute everything here. Okay, so 1 by TB mod V of f whole square into, I'll divide this. First I'll take n is equal to 0. N is equal to 0, e power 0 will be 1. 1 into Ra of 0. It will be Ra of 0 plus summation n is equal to minus infinity to plus infinity. But here n not equal to 0 because I have taken n separately. So it will become Ra of n into e power minus j 2 pi fn TB. Okay, from this equation I've got this. Okay, now again I'll substitute the values. 1 by TB, mod V of f is nothing but, TB sinc FTB whole square into Ra of 0 is nothing but A square by 2. Okay, third equation I'm substituting. Okay, third equation is this one. When n is equal to 0, it is A square by 2. Okay, that's what I've written here. Plus summation n is equal to minus infinity to plus infinity and n not equal to 0. Ra of n is nothing but A square by 4. Okay, when n not equal to 0, Ra of n value is A square by 4 e power minus j 2 pi fn TB. Okay, so now what I'll do, I can take this outside because it is independent of n. So I can write it as 1 by TB mod. Okay, here I can just write it as TB whole square, TB square sinc square FTB. Okay, into A square by 2 plus A square by 4 summation n is equal to minus infinity and n not equal to 0 to infinity e power minus j 2 pi fn TB. Okay, so this TB and this TB will get cancelled, so I'll be left out with TB sinc square FTB into A square by 2. Still I'll do, see, until here is the concept. From here it is all the mathematical derivation. Okay, until here is the concept. Okay, I've just substituted, then I've taken common everything. Until here, dustbin. Okay, so until here it is all concept. Okay, and from here it is all the basic mathematical substitutions. So a square by 2 plus a square by 4. Here what I'll do, I will do one small analysis here. E power minus j 2 pi fn tb. Okay, and to this number, to this e power minus j 2 pi fn tb, I'll add plus 1. I will add plus 1 and minus 1. Will it change the meaning if I add plus 1 and minus 1? Will it change the meaning? Will it change the meaning? If I add plus 1 and minus 1 to this number, will it change the meaning?
No, no.
It will not change the meaning. Okay, so a square by 4. Okay, this a square by 4, I'll multiply it to this and also to this. Okay, so let me write it separately as summation n is equal to minus infinity to plus infinity, n not equal to 0, e power minus j 2 pi f n tb plus 1 I'll take to this, and this a square by 4 I'll multiply to this minus a square by 4. Anybody has doubt in this? You can ask me. tb sinc square ftb into a square by 2 minus a square by 4, it will be a square by 4 plus a square by 4 into summation n is equal to minus infinity to plus infinity, minus infinity to plus infinity, n not equal to 0, e power minus j 2 pi fn tb. This 1 can I write as e power minus j 2 pi f0 tb? Can I write in this way? E power 0 only, no? It is nothing but, see, this 1 I have represented in this way. Okay, so that again it will be e power 0 only and it will be 1. Okay, right, but here in place of n I have substituted 0. That's all. Will it change? Is it fine? Anybody didn't understand? You can ask me. Okay, so this is equal to tb sinc square ftb into a square by 4 plus a square by 4. Here what I can do, see, this is also getting added to this, right? So what I can do, I can include this n is equal to 0 with this, so that it will become n is equal to minus infinity to plus infinity e power minus j 2 pi fn tb. I don't think you people have doubt here. Okay, if you have any doubt, you can ask me. Okay. Oh, one more thing. Now what I'll do, multiply this to this complete term. Okay, so this will be equal to a square tb by 4 sinc square ftb plus a square tb by 4 sinc square ftb into summation n is equal to minus infinity to plus infinity e power minus j 2 pi fn tb. Okay, fn tb. This is the sx of f. Still further simplification is possible. Sx of f. Still further simplification is possible. So here any one of you remember the Poisson's rule? Poisson's rule. Poisson's formula. Again, you need to remember this formula. Remember Poisson's formula. Anybody can tell me? Anybody heard this name before?
Yes, ma'am.
Okay, tell me what it is. If I have exponential e power exponential term, and if it is if the summation is taken from minus infinity to plus infinity, it will reduce to 1 by tb times of summation m is equal to minus infinity to plus infinity delta of f minus m by tb. This is your Poisson's rule. Okay, so this I will substitute in this equation. Okay, let me name this as 4 and this I'll name as 5. Okay, so substitute 5 in 4. Substitute 5 in 4. Okay, so it will reduce to Rx of f is equal to a square tb by 4 sinc square ftb plus a square tb by 4 sinc square ftb. In place of this function I can write as this one, 1 by tb into summation m is equal to minus infinity to plus infinity delta of f minus m by tb. Okay, so this tb and this tb will get cancelled and I'll be left out with s x of f is equal to a square tb by 4 sinc square ftb plus a square by 4 sinc square ftb into summation m is equal to minus infinity to plus infinity delta of f minus m by tb. Okay, so still we have further analysis. Further analysis I'll do in the next class. Today I'll be taking even afternoon class also. Okay, because you have hardly 1 more week to go. So I'll be taking additional, actually you have got 2 classes today, right? Thursday you have first hour and fifth hour. Okay, today I'll be taking fifth hour class also. Okay, and continuation of this I'll do in the next class, because now it's already 9:55. If I start the further analysis, maybe time won't be sufficient. Okay, so that is the reason I'll take afternoon class also and I'll teach you. Okay, any doubts you have got until here, you can ask me. Any doubts you have got until here, you can ask me. Any doubts you have? Or you want me to just revise everything? Revise from the beginning?
Yes, ma'am.
Okay, fine. I'll just do it in 1 minute and then you can leave. Okay, so the general formula to calculate power spectral density is this equation. Okay, so here V of f is nothing but the rectangular function and Ra of n is nothing but the autocorrelation of the random variable ak. Okay, so that you need to find the formula to calculate Ra of n is nothing but this is the formula. I is equal to 1 to I ak minus n I pi. I is the number of products. Okay, that this I indicates the number of products. Okay, so now the NRZ unipolar NRZ, the format will be in this way and each bit will be of TB duration. Okay, and if you observe, my AK will be either a amplitude can be either a or a 0. Okay, if I have symbol 1, the amplitude will be a. If I have a symbol 0, the amplitude will be equal to 0. Okay, so that is the reason here I have mentioned that each bit duration of TB seconds. Okay, and then I have taken the power spectral density equation. Here instead of T, I have replaced T with TB because each bit duration is TB seconds. Okay, so that is the reason wherever I have got T, I have replaced with TB. Okay, then you have V of T. In the first step, I see here what I need to do. If I want to get Sx of f, I need to know what is V of f and also what is Ra of n. Autocorrelation function value I need to get and also the V of f I need to get. So for that reason, I have taken V of T. V of T is nothing but rectangle T by TB. For that, the Fourier transform is TB sinc FTB. Okay, so we have got V of f. Okay, that I have named as equation 2. Okay, next I need to calculate Ra of n, autocorrelation function. Autocorrelation function I need to find. So for that the formula is this. Okay, and here now what I need to do, I have to take different cases when n is equal to 0, when n is equal to 1, 2, like that. Okay, but here I will just take two cases when n is equal to 0 and when n is not equal to 0. Okay, so first I have taken when n is equal to 0. When n is equal to 0, this is how the autocorrelation function will be. This is how the autocorrelation function will be. Wherever I have got n, I have replaced with 0. So ak minus n will reduce to ak. Okay, so since I have product as ak, the possible products that I'll get will be, see, ak can be either a or 0. If ak is a here, and the next ak will also be a. If the ak is 0, the next ak will also equal to 0. So two combinations only I'll get here. And the product a into a is nothing but a square, 0 into 0 is nothing but 0. So the number of products that I'll be getting here is 2. Okay, so again I've written the equation for RA of 0. And one more thing is the probability of getting this and getting this I need to find. Okay, the probability of getting this is only one probability. So one occurrence divided by total number of occurrences 2. The event that it will occur is 1 and the total number of events are 2. So 1 by 2. Okay, so RA of 0 is equal to summation I is equal to 1 to 2 because I have only two products ak of I pi. Okay, now I need to just take the product and into the probability. So a into 1 by 2 plus 0 into 0 1 by 2. Okay, so I'll get as a square by 2. Okay, so this is when n is equal to 0. Now when n is not equal to 0, I need to find out how many products I'll get. Okay, so for that, since n is not equal to 0, I may have ak minus 1 or ak minus 2 or ak plus 1, something like this. Okay, I may have like this. So what are the possible products that I may get? So let me consider ak is 0. Okay, if ak is 0, the next one it can be either a 0 or a. Okay, so a into 0 is 0, a into a it is a square. Next again ak can be 0. The next possibility can be either a or a 0. So 0 into a, that is equal to 0, 0 into 0, that is equal to 0. So that number of possible products that I'll get when n not equal to 0 is 4. And so the probability for each combination will be like 1 by 4. Okay, so the probability of each will be 1 by 4. Now again I need to find RA of n. So I have taken the product term a 0 into 1 by 4 plus a square into 1 by 4, 0 into 1 by 4, 0 into 1 by 4. So I've got as a square by 4. Okay, so the overall result of autocorrelation I've represented here. RA of n is equal to a square by 2 when n is equal to 0 and a square by 4 and when n not equal to 0. Okay, then finally I've substituted v of f whole square value in this and RA of n in this. Okay, so here n is equal to minus infinity to plus infinity I have. So I've calculated when n is equal to 0 separately, right? So I've separated the terms. RA of 0. You may ask me where this term went. It will become e power 0, right? Because n value is 0. So this will be equal to e power 0. E power 0 is 1. So that is the reason I've got only RA of 0. And here, since I've already substituted n is equal to 0, here my summation, I'm taking it as summation n is equal to minus infinity to plus infinity, but n not equal to 0. Okay, so then after that, I have substituted RA of 0 value and RA of n value. Then what I did, I've taken, anyway, this is independent of n, so I've taken it outside. After taking it outside, for further analysis, we are extending the mathematical analysis. So what I'm doing, I'm adding plus 1 and minus 1 to this. So I've added plus 1 and minus 1. And then again, what I did, I have multiplied this square by 4 inside, so that for these two terms I have taken together and for this term separately. Okay, so again, if you observe, I have a square by 2 here and a square by 4 here. So a square by 2 minus a square by 4, it will reduce to a square by 4 here, a square by 4. Okay, and here in place of plus 1, I have written as e power minus j 2 pi f n value I have taken as 0 TB. Okay, so this term again reduces to 1 only. It will become 1 only. Okay, so that is the reason I've written like this. So now summation, it is addition to this will get added. So n value I have taken it as 0, so this will get added. So even n is equal to 0 will get added to this. And so I have n is equal to minus infinity to plus infinity. Before I didn't had n not equal to 0, but now I have got n equal to 0 also. So that is the reason all together I have represented like this. Okay. Now after representing in this way, I have just multiplied this outside term to inside. Okay. Then finally I've got this equation. Now again, for further analysis, I have replaced this entire thing with delta function, which will be obtained by using the Poisson's formula. Okay, so from this I have substituted in the above equation, so that finally I've got this equation. Okay, so after this, still we have further analysis to plot this Sx of f. Okay, I need to practically see how the Sx of f function will be. Okay, so further analysis we'll do it in the next class. Okay, again 5th hour I'll be taking. Don't miss the class. Okay, thank you. Anyway, tomorrow is a holiday. Again, Saturday is a working day. I think you people would have got the updated calendar of events. Hardly you have holidays. Okay, fine. That's all for now. If anybody has got any doubts, you can ask me, or else you can leave. I don't know how many of you are there because it's already time up. Okay. Okay, fine. Okay. You can leave now. Again, we'll meet in the 5th hour class.
Thank you, ma'am.
Oh, Deepshi. 2015-17 batch. You people have some other class today, no?
Yes, ma'am.
Oh, then I cannot take. Okay, fine. I'll take on Saturday only. Okay. Okay, I'll not take any class today. Okay. Please inform to the people because I have to combine and take. The other section has got some other class, so I'll not be able to take the class. Okay. So Saturday only I'll continue, but make sure that you remember all this. Or else if you people are okay with, after your last hour class, I will take only for further analysis of this, only this derivation I'll finish and I'll leave off. Is it okay? Shall I take that time? I may need 10 to 15 minutes. That's it. Okay, I'll take on Saturday only. Nobody is answering. Okay, fine. Thank you. Bye bye.